Hi students, this chapter we are going to look at speed of reaction or the rate of reaction. So in chemistry, not all reactions occur at the same speed. There are some reactions which occurs very fast, some reactions which occurs very slow. Okay, so these are the examples. And then measuring the speed of reaction. So we measure the speed of reaction by measuring quantity of reactants. Reactants will decrease with time, or by quantity of products, and this one will increase with time, or we make some observations that we can see usually in terms of color change. Okay, speed of reaction is inversely proportionate to time. So what does this mean? It means the shorter the time, the faster the speed of reaction. The longer the time taken, the slower the speed of reaction. Okay, so to measure the speed of reaction, we usually use three methods over here, and these two methods are the most commonly used methods. So number one, the first method is to measure the mass loss over time. So the mass loss of my reactants over time. So in a chemical setup, this is how we usually set it up. If they ask you to draw, we really have to draw and label it this way. Okay, so example, if I have a carbonate plus an acid reaction, so I put the carbonate inside and then I pour in the acid and then I put it on the electric balance and I put over cotton wool. So the gas produced, it will give me salt, carbon dioxide and water. The CO2 gas escape. So over time, because the product escape, this reading will decrease. Okay, so over time, 1 second, 2 seconds, 3 seconds, take note of the readings and then tabulate it into a table. And if I plot these values against time, I will get this graph. This is a decreasing graph and this is your decreasing graph. Okay, important thing to note over here is that the graph will not reach 0. Okay, it will not reach 0 because CO2, salt, and water is being produced, and salt and water is left behind. So there's still some components that are left. Okay, this experiment setup, repeat myself, this is using mass loss, and this is the setup that we do. Okay, we can also measure speed of reaction by product formation. So product formation, same thing in a carbonate reaction. I have to capture the CO2 that is being given out over here. So I measure the volume, not just to capture it, I also have to measure it, and I measure it using a gas syringe. And the CO2 being produced will actually increase over time. You can see that it's increasing over time. And the graph will be an upward graph. Okay, so look at this A, B, and C. A, B, and C. If I draw a tangent to the graph, okay, A will be the steepest, B is less steep, and C is practically horizontal. Likewise, A is the steepest, B is less steep, and C is almost horizontal. Okay, so interpretations of the graph, let's look at it. Okay, at A, gradient is the steepest and the speed of reaction is the fastest. So the steeper the gradient, the faster the rate of reaction. At B, gradient decreases. Why does it decrease? The speed becomes slower, right? It is slowing down with time. Why? Because your reactants are being used up. And at C, gradient is 0. So let's look at C again, right? This is almost horizontal, this is almost horizontal. Horizontal means there's no gradient. No gradient, reaction has stopped, okay? Because all your reactants have reacted completely. Okay, note that the first graph, the mass of the flux does not go to 0, as mentioned, right? Because salt and water will be left behind. Okay, so the first two examples are very common examples. Then we will have observations over time. So these observations over time is not as accurate because there will be what we call random errors. Meaning to say, these are caused by human error. Okay, so common example of measuring observation. This is a common reaction. Right, in this reaction, what is more important is that you know the products is sulfur, and this sulfur is a yellow solid. So at the start, I have example sodium thiosulfate. This is colorless solution. HCl, also colorless solution. Give me a salt. This is colorless. SO2 gas escapes, and then water, colorless, yellow solid. So to observe the rate of this reaction, usually I'll put the mixtures, the reactants in a beaker, and then I'll put a piece of paper and I draw it, a cross on it. So because this is colorless, at the start, I can see the cross very well. And then as your reaction proceeds, you know, sulfur is being formed and it turns a little bit opaque. And then once your reaction complete, all your sulfur is formed, and because it's a solid, it's yellow, I cannot see the cross anymore. So I will stop the stopwatch when I am unable to see the cross. And this reaction is subjected to random human errors because different people see the cross a little bit differently. This experiment setup is not the most accurate to measure speed of reaction, okay? But in the practical, it is possible that they will ask you to do this experiment setup.